Yeah, hey, I'm Jonathan Lim, product manager at Circle for our cross-chain transfer protocol. So what the CCTP is it's a network. It's set an on-chain contract, but really it's a network that allows developers and end users to move USDC natively through burn and mint across chains and creates an interoperable financial network. So today I want to frame the discussion through a lens of interoperability and how interoperable networks evolve. And then also have it be a conversation. I want us to all be kind of engaged. Feel free to raise your hand anytime. I'll pause and I'll take questions. So we'll do it that way. Okay. So I want to start with a little historical anecdote here. So this is actually a railroad map of Denver in, I believe, 1890. And interoperability, I think what I would argue is the first major interoperable network in the world was modern railroads, right? And railroads actually haven't changed that much since their inception and their widespread use. And it's funny here, we're at ETHDenver, which people say the conference is kind of mid, but it could have been ETH Golden. Does anyone know where Golden, Colorado is? Okay, that's some head nods. That would have been even more mid. And so Golden is like about 20 miles west, I don't know, give or take. And back in 1850s, Golden was actually the capital of the Colorado territories. And Denver was not. They were both founded around the same time. And Denver actually became the capital, I believe in like 1867, took that mantle from Golden and eventually went on to become the capital of the state of Colorado at the time, those territories. One of the deciding contributing factors in my hasty research was the ability for Denver to connect itself to the larger network of the United States and the Transcontinental Railroad. So basically in the early 1860s, Golden and Denver both raced to build the first rail connection directly to Cheyenne, Wyoming, connecting them to the rest of the global economy or the US economy at the time, right? And alas, the Denver Pacific Railroad Company beat out the Colorado Central Railroad Company for that title. And a month later, so they broke ground, like I think in November in 1867, and a month later, Denver was able to take the mantle and become the capital of the Colorado Territory. So, history's complex, and I've only distilled it down to one dimension, but the power of interoperability is real. Networks typically have three dimensions, and I think this is quite universal. They have speed, right? In the case of rail networks in the US, because in some ways we're like a third world country, like rail speed hasn't really changed, right, over the last like 200 years. Network size has grown, and the network size growth of US rail networks has been arguably one of the most important contributors to the success of the US economy. And then there's payload or content, right? Or data format. And these are sort of the universal dimensions of networks and roll up to what I think people call interoperability. I hear a lot about interoperability. I was chatting with someone from Ethereum Foundation yesterday to join like interoperability working group, and it seems like a lot of folks are stuck on like why their interoperability solution is better, when I think we need to actually go down to kind of definition of like, what do you believe interoperability is? So today's, I want to talk about CCTP v2 through the lens of mostly speed and interoperability. V1 proved out the thesis of network size interoperability, and I believe we're on like 10 or 11 chains right now. And V2 will expand on that, but also introduce the added dimension of improvement of speeds. And we all know that network speeds are critical. You look at, aside from rail networks, which really haven't improved, air travel has improved, right? Telecommunication networks, internet. Folks have probably read like, what was the book by, the guy wrote The Big Short, but talking about how trading companies like laid their own fiber, right, to get like cutting edge speeds. So the pursuit of speeds in networks, and especially financial networks, is critical. All right, so quick recap of how the CCTP is done performance-wise. V1, We've done over 2 million individual transactions since launching in, I believe, April 2023. Over 35 billion cumulative volume. This is probably stale. I think we finalized these slides like a week ago. Last couple months, due to the bull market, we've been doing anywhere from like 5 to 8 billion a month in cumulative transfer volume. And this is all in native burn and mint USDC. And on the routes we are on, we represent 98% of all USDC bridge, give or take. Of course, that fluctuates. So speed's important. I won't read this slide, but the TLDR is we've architected a way to increase speeds by orders of magnitude to improve existing use cases and improve existing use cases and unlock new ones. And the way we do that is we have created the ability for developers to fetch a sub-finality attestation. So the way CCTP v1 works right now is we just essentially subscribe. That's not like a technical term, but adhere to a chain's finality. So on Ethereum, that's like 65 blocks. That's 13 minutes, aka an eternity. And on other chains it varies, but generally the EVM is quite slow. So we're launching on Ethereum based in Avalanche as our initial tranche. I'll just describe the experience and rather than just kind of describing like the high-level architecture. So I'll walk you through experience here. So as a developer, you submit the transaction, initiate the burn on Ethereum. And on V1, CCTP V1, what you'd have to do is you would have to wait for 65 blocks on Ethereum, and then Circle will sign the transaction. You fetch that attestation, you submit it to the destination chain, and the mint happens, and the developer user gets their funds. Well, in V2, we have enabled developers to fetch that attestation at a predetermined sub-finality tier. And I can go into that kind of in a Q&A. It's really interesting. But we've determined, for example, on Ethereum, that we will sign it at 2 blocks. So a block is about 12 seconds, I think, on Ethereum. So if you add the blocks and some off-chain processing time, et cetera, you're looking actually at around 30 to 45 seconds end-to-end moving USDC from Ethereum outbound, which is amazing, right? It's orders of magnitude faster. And then on Base, it's essentially the same. Avalanche is a single slot finality chain, so we don't accelerate it, but we have included Avalanche so that you can actually stitch together Avalanche or the V1 network with V2 temporarily while we expand the V2 network, and using Avalanche as like a hop chain, essentially. Questions here? So cool, people are speechless, awesome, okay. Great, oh, okay. You always have to wait and then, break the ice a little bit and suddenly people won't stop asking questions, which is good. Go ahead. No, it's not. So the token contract is distinct, it's separate. We have the USDC token contract. The CCTP is its own set of contracts, right, which invoke the token contract. And then the sub-finality architecture, that is off-chain. So the CCTP and all bridges have an off-chain component that actually does the bridging, right? And it's that's what we use we basically like watch a node, right, and watch when n number of block height is hit, and then we're like, okay, we're gonna sign that. Yes. Get to you in a sec. Yeah. Yeah, great question. Okay, can I pin that? Okay, I'm definitely going to come back to that, and we can riff on that. In the middle? Okay, cool. Let's like cluster all that together, and we can riff on that in the back there. Oh, interesting. Yeah. No, I haven't looked too into that. Maybe after this we can chat and you can kind of tell me a little more. Okay. Yeah. Oh, interesting. Got it. Okay. And to answer kind of half of your question, so okay, we are serving a sub-finality attestation, right? So there's risk. What's the ultimate risk we're trying to solve for? It's a double spend situation. So we've done a ton of analysis to show that the probability at 2 blocks on Ethereum, for example, with the frequency of 2 block reorgs on Ethereum, which I think is in 1 calendar year back from now, I think it's only been two of them. We are okay with that risk. There's some expected value calculation on the loss, and that's all baked into a concept called the fast transfer global allowance, which is an over reserve. It's a buffer. And that allows, so in the case of a double mint, the buffer eats that double mint essentially, and USDC never becomes under reserved. Yeah. That's okay. Yeah, come back, yeah. Mm-hmm. Yeah, sure. I wish, so apologies, this was a just kind of generic slide deck, and I wish I had made kind of a more technical one, but so. Mm-hmm. Exactly. So, okay, you have it now? Go. Don't lose it. Yeah, totally. Yeah. So definitely a risk. The type of reorgs, there's 2 kinds of reorgs, right? Natural reorgs and malicious reorgs. V2 and fast transfer paradigm only addresses and lives in the world of natural reorgs. Malicious reorg, we have a massive security team, right, that basically deals with that. You can't predict a security attack. If you can, like, you wouldn't be here, you'd be on your own private island, right? So that's kind of how we think about it. Like, yes, that's a risk. There's no way to quantify that and like create a buffer that is real, right? Like, you can't take, so that's kind of the answer there. But to elaborate on, to give a little more thorough answer on what Ben's question was, so we're going to market with probably around $6 to $10 million global fast transfer allowance. And the way this thing operates, and if you're a developer, we have an API endpoint and you can query that every time, but only that amount, up to that amount, is what can be in flight in terms of the delta between sub-finality attestation served and confirmed. So the way the allowance calculates this is if someone burns $1,000 and we serve them that 2 block attestation for the next 13 minutes minus 45 seconds. So let's just say it took 60 seconds, okay? So for the next 12 minutes, we subtract $1,000 from that allowance. And then once full confirmation is hit, then we restore that $1,000. And this happens, multiple hundred times a second. We've sized the fund with a bunch of historical data, and hopefully, it supports like a very high SLA, over 99.99, whatever, we'll see. And we have the ability to quickly modify that fund as well. Yeah. Yeah. Yeah, it would be Circle. And this is also why we're charging for it, right? I mean, all cross-chain speed solutions are have BIPs anyway, so it's not like that's novel. But yes, we are. Let's just say 6 million. It might be 10. I have to kind of do some kind of last minute calculations, but or on the order of millions. Yeah, and again, that will change, right? Like, as demand increases, we will increase that amount to ensure that anyone is able to So right now the burn limit, which effectively becomes like the message limit, is about $1 million. And actually, there's not too many $1 million transactions. Most transactions on the CCTP are within, like 3 to 5K range. So we've done all the math to kind of size it properly and say, okay, like with these types of transactions, and that amount of like sub finality to full finality diff time, we need like X amount of million. Yeah. Yeah. No, this is a community event. Come on, let's go. Yeah, so great question. So that risk assessment of the chain we're dealing with was baked into the speed we're offering. So for example, Polygon. Just stating facts here, okay, I'm not throwing shade on Polygon. Polygon reworks quite frequently. So we have been able to calculate like, so that, for example, that Ethereum, like the 2-block rework frequency, if you want that same probabilistic frequency, that's a different block depth on Polygon. It's somewhere in the teens to like the low 20s. And that's how we normalize it, essentially. Yeah. Rather than, what was your suggestion or question? Yeah, adjust the speed, because actually it's more economically efficient to have a global allowance. Yeah, it's essentially like a utilization problem, right? Yeah. Great questions. I hit both of my timers, I guess. But should I keep going? Okay. What if I just left right now? Okay. All right. So quick feature overview. V1, was our first crack at this, really establishing the network. V2 is going to build on that. So it's a superset of features. There's nothing going away. We still have standard transfer, which is internally we call it slow burn, which I like. It's a little derisive, but standard transfer, which uses the full finality of a given source chain. Now, when you're on a fast chain, so for example, we just shipped to Aptos and Sui, and also we've been on Avalanche, right? Like those are fast. You will leave, Avalanche, Sui, or whatever, and get an end-to-end time around like anywhere from 20 to 30 seconds, depending on where you're going. So that's still there. And we are introducing fast transfer. The plan is going to be probably go to market at around 1 BIP, and that gets paid ultimately by the developer. So there's also an API endpoint where you can check to see what the latest fee is. That fee, I don't plan on that fee being volatile, right? So, but as a best practice, if you're a developer, you're going to want to hit the global allowance endpoint and the fee endpoint like every time, right? That's the whole point of having an API. Otherwise, like we would just write it in our docs. And then we're also introducing hooks, which basically enables all kinds of post-mint composability. The possibilities are endless, as you guys know, and we're doing this in a way where developers basically have to kind of handle like hook success or failure. There's too much complexity in having Circle deal with that, because then you could have a mint like be unredeemable, which is a bad situation. So, and then blockchain support. This is the V1 network right now. Unichain was our last V1 expansion, and now for everything will be on V2 from now on. So V1 network will remain, but we're going to basically backfill all these chains and then add new ones throughout the rest of this year. So super exciting. I would say by the end of 2025, the V2 network could be almost 2 times the size in terms of number of nodes as the V1 network. And then, if you want to use like a Metcalfe's law type of thing, like obviously it's more than linear, so more than twice as valuable to be on the V2 network. Okay, this is just a little riff on new and existing use cases. Looking ahead, already kind of covered this. Yeah, let's go to questions. More questions, unless you got us. Go ahead. Yeah. Yeah. So V2 is architected in the same way as V1, which is it's technically a generic message passing contract, and with USDC being an instance of a generic message, right? So, on V1, the only thing you can't do is, this is kind of annoying. I mean, I think we regretted this decision, but on V1, you can either send a generic message like bytes type, or you can send a USDC burn. You can't do both. You can't append a generic message. On V2, that's what hooks does, right? Hooks is essentially an appended generic message. Yeah. It's the same. That's correct. Yeah, that's correct. So, many bridges do that for you. Sometimes they don't. And then, you can use like a relayer service to like go fetch it, or you can get it yourself if you're sophisticated enough. Yeah. Right. Yeah. So I'm definitely not a security expert, but in the conversations we've had with our security team, the max loss, for example, right? Like if you rapidly burned 10 $1 million transactions and had $10 million that you're trying to reorg, because that's the size, or like 6, whatever the size of the allowance is, right? So let's just go 10. The cost of you doing like a consensus attack needs to be like way less than 10 million for it to be like worth your time. Yeah. Yeah, I mean, it's very hard to quantify, but it's like a qualitative assessment on our part that says, okay, like a hacker really needs to put a lot of work in to like reorg the specific block, like catch all the transactions, make sure they're included in that block, and then again, like the cost of doing that consensus attack be worth the money you're gonna steal in this case. And I generally, like, the sense I got was that $10 million is like not that much to steal if you're gonna do a consensus attack on Ethereum. Like there's probably bigger fish to fry, but yeah. Right, yeah, then like Optimism just got like completely hacked, right? Is that what you mean? Yeah. Yeah, I hope that doesn't happen. Yeah. Right. Totally. Yeah, I mean, it's a fair question. I don't have like a on this malicious reorg vector. There's no concrete answers. And like at the end of the day, like we understand that we have this risk posture, and we decided like the risk is worth it, And okay, like if an attack happens, not great, right? What's USDC circulation is like 56 billion right now. 10 million, I think we're ready to deal with that. Yes. Oh yeah, did I answer your other question? Okay. Yeah, great question. So Unichain's on OP Stack, centralized sequencer. So our approach for that is so OP did have a reorg. They had like a reorg on like February 15th, like 2024. I think it was like a bug or something. It was like an internally generated reorg. But taking that into account, we're still comfortable with like one L2 block. So that's like 2 seconds. So take 2 seconds and then add on like some processing time, and then depending on where you're going, like catching the block on the mint side. I would guess anywhere from like 15 to 20 seconds plus or minus. Yeah. Yeah, we're still doing some profiling now, but we're seeing some like really promising numbers. Oh, lower. Yeah, yeah. Like end to end, but going to L2 to L2. That's what I'm saying. Yeah. So it depends, right? Yeah, and then if you're going to Ethereum, then you have to like wait for an ETH block, and you might, depending on where you catch the block. Yeah. Great question. Okay, I'm being clapped off the stage. Thank you, everyone. Thank you.